Next is an application problem that you will likely see on exam and final exam. The first one say, after graduating from college, you got 2 job offers. A job with a yearly salary of $30,000, so that's your starting salary, with an expected yearly pay raise of $1,100 a year. And the second offer also start at $30,000 a year, with a pay raise of 3% per year. So please come up with a formula that will help you to calculate the salary for the nth year. So any year for each offer, which job is a better offer? What is your yearly salary for each job during the 20th year of the job? So let's look at this together. So we have 2 offers. The first one, you get $1,100 more each year. So what do you think that, what kind of sequence that is? So hopefully you know the first one is an arithmetic sequence because they're adding $1,100 each year. So this is an arithmetic sequence at $1,100 each year. All right. It would be helpful if we can list a few years and try to come up with the formula, right? So I'm going to need to do the first year, second year, third year, fourth years. So sometimes people may say, okay, like if I figure out what is 3% of $30,000, then I can quickly think of which offer is better, right? So I know one is $1,100 per year, but how about 3% of $30,000 for the second offer? So that one, if we want to find 1%, basically we move 2 decimal places, right? So 1% of 30,000 is going to be 300. So 3% is 3 times that, is going to be $900, right? So $900 look like 3%, only $900, but the other offer had 1,100. So at this moment, the job offer A sounds better, but it may not be always true. So we're going to calculate that. Okay, so let's see. If we have the first year, how much are you going to make? Just 30, right? 1,000, right? Because you're not going to get a pay raise like before you get started, right? And the second year, we're going to have 30,000 plus 1,100, right? Because you can expect this pay raise each year. And the next year, you're going to copy what we have from the last year. And then you get another pay raise, right? And then the next year, we copy from the previous year. And then add one more, 1100, right? So if we try to clean that up, then the last one, we will start with 30,000. We need to add 1,100. And then we have 3 of these, right? So it's going to be multiplied by 3. And the year before that, we started with 30,000 plus 1100, and then we have 2 of those, so it's going to be times 2. And the year before that, 30,000 plus 1100, you have 1 of those, so times 1. And the very first year, we're going to do the same thing. And then how many 1,100 do we have? We don't have any, so that need to multiply by 0. So hopefully you can see the patterns of whatever you're multiplying. It's going to be 1 less than whatever year that is, right? So if we need to calculate the nth year, we can follow these patterns. Every time we are starting with 30,000, plus 1100, right? And then we're going to multiply a number 1 less than the year. So if the year is n, we need to subtract 1, right? So they also want to know the 20th year. So the 20th year also will start with 30,000 plus 1100 and then multiply 2. My year is 20, need to subtract 1, right? So essentially, I need to multiply by 19. So 30,000 plus 1100 times 20 minus 1 is 19. So you can use your calculator. We have 1100 times 19. So after 19 years, the pay raise was 20,900, but I need to add back my $30,000. So totally, I'm going to make an okay wage after 20 years, right? So my answer is going to be $50,900. So this is for offer A, and this is 20th year, right? Okay, so we did the first offer. And let's look at the second one. The second one, I'm going to get 3% more every year, right? And initially, we figured out 3% of 30,000 is only $900, right? So it looked like at this moment, A is better. So how about long term? We're going to see. The second one, because it's 3% more each year, so it's considered as a geometric sequence. So again, I'm going to list the first 4 years. So first year, second year, third year, fourth years. And again, the first year I only make 30,000, right? I'm not going to get one pay raise yet. And then the second year, we're going to copy the 30,000. And then this time, I'm going to need to get a 3% pay raise, right? So be very careful with this because like a lot of students make a mistake here. So I'm going to write it down here. So some students think it's going to be 30,000 multiplied to a 3%. So earlier we already figured that out, right? 30,000 times 3% is same as 30,000 times 0.03, right? Because when you change percentage to decimal, you basically percent mean per 100. So it's 3 per 100. 3 divided by 100 is 0.03, or you can think of it as just moving 2 decimal places to make it a smaller number. So if we multiply that, we already know that's $900, right? So if you do that for second year, you're going to be in trouble because like last year you make 30,000, this year you only make $900. That's not enough, right? So $900 is only your pay raise. So the 3% is only your pay raise. So if we want my original 100% of salary plus the 3% pay raise, I should not multiply 3%, right? I should multiply 100% of my salary and 3% more. So essentially, instead of multiplying by 3%, I should multiply it by 103%. So if you multiply by 103%, then you will have 30,900 more. So together, it should be $30,900 for the second year, okay? So I'm going to write down, this is multiply 1.03 because it's supposed to be 100% plus 3% more, which is 103% here, right? And if I change 103% to a decimal number, that's what I have, right? So the next year, we're going to have 30,000. And then I'm copying from the last line, 1.03. And then I need another 3% pay raise, right? So I need another 100% and 3% more. So the next year, I'm going to copy what I have from the last year. And then I need another 100% and 3% more, right? So when I clean that up, the fourth year, we started with 30,000. And then this number times itself 3 times means 1.03 need to raise to the third power. And then the year before that, start with 30,000 times 1.03. This time only have 2 of those, so square. And the year before that is going to be 30,000 times 1.03. I only have 1, so to the first power. At the very beginning, I have 30,000 times 1.03. I didn't multiply it, so I would put a 0 power there. Anything times 0 power is 1, right? So 1 times that 30,000 is still 30,000. So that looked like it cleaned up correctly. So hopefully you see the patterns. Whatever the exponents you have is going to be 1 less than what the term is. So if we need to find the nth term, we're going to have 30,000 times 1.03. I need to use the n, but I need to subtract 1, right? So this is the nth term formula. If I need to find the 20th term, again, for this particular sequence, we're going to start with 30,000 times 1.03, and then we're going to have the 20th term subtracting 1, which essentially we are raising it to what power? 20 minus 1 is 19, so be careful. We're going to need to use a calculator. I'm going to do 1.03 raised to this caret top button, so make sure you know where to find it, raised to 19 power, and then this number need to times to my 30,000, right? So this give me $52,605.18. So this is for job offer B for the 20th year. So when they ask you which one is the better offer, so we have to be careful. We need to think about it. At the beginning, for the second year, if I stay with job offer A, I got 30,000 plus 1,100, right? So this is $31,100. But if I do the 3%, here I only get $30,900, right? So job offer A is better at the beginning, but after 20 years, A give you 50,900 and job offer B get you $52,605.18, right? So it looked like for short term A is better, but for long term B would be better. So I'm going to say for short term, job offer A is better. For long term, job offer B is better. So you may see exam questions similar to this.